Okay, I'm going to, yeah, I'll take a simple case. So it is, it may be a simple two-dimensional square tube. Okay? A simple square tube of particular dimension. So whatever it may be, we take some dimension and we try to solve it. Okay, we take a simple square tube. Okay, so the square tube dimension, let me go in this thing. So if I take a the length is of some 20 centimeter or 200 mm, whatever it may be. So this is my square tube. Okay, this is the length. This is my, I'll draw the side view also. I'll try to show you. This is my tube, and this is the, if I take the center axis, and if I look from the side view, this is what I want to see. It's a simple square. Just one minute, I'll try to show you. This is my, yeah, this is the square actually. Okay, so this will be a side B of 2 centimeters or 20 mm. This thing, and the length is of 20 centimeters. That is around 10 times this particular thing. I'm going to take. See, when I try to solve this using incompressible fluid, so I'm going to use the incompressible Navier-Stokes equation or Euler equation. So this is the size of it actually. Now, so if I want to solve this problem, maybe if I take it on a simple, what we call it as maybe isometric this thing, the isometric, the pipe will look something like this. This is how it looks like. Okay, this is how it looks like. Simple thing. This is how it looks like in the isometric view actually. Okay, in the isometric view, this is how it will be looking. Okay. This is how it is looking. I'm making everything dark so people can understand. That's it. There's nothing like, okay, this is what I have. And this is inside one, this is broken. Okay, this is a broken line. This is invisible. This is invisible. This is invisible. Okay, this is what art I have. Now, here the most important thing is the vertices. Okay, suppose if I going to fix this particular thing, say suppose if I fix it, the most important thing what we try to do in your OpenFoam is, so if I want to put it in the block mesh dict file and all, I need to define the reference frame. So if I define this as the reference frame, this as my reference, so I'm going to give this as my y-axis and this as my x-axis. See, this is a rule what I'm trying to discuss actually. So it can be xy or xz, whatever it may be. So, or let me go with the yz also doesn't matter. Okay, if I define it yz, so this is your x actually. So if I define this as my length as this x, so this is y and this is z. I'm going to define this also. I can define it x, y, z. So whatever you want to define, you should be very clear with it. Now, once I define it actually, I told that you have to start with the bottom one. So if I try to define the numbers, so this will be 0, 1, 2, 3. Okay, then I'm going to start with the top one, 4, 5, 6, and 7. So I have defined the vertices. So once I define the vertices, I should able to go to your block mesh dict file and define these vertices. Okay, define these vertices. So if I want to define these vertices, So what should I do? So let me write that vertices. Then the same thing we are going to type in the block mesh dict file. Okay. So let me write that. See, whatever the rule I am trying to tell, this rule is applied for almost all the things. What is this vertices? Vertices means it is the points. I need to define the coordinates x, y, and z. Okay. Now, what is corresponding to 0? For 0, it is 0, comma 0, comma 0. Okay. Now, for the 1, okay. So, for the point 1, so already we know the dimension. So, if see, this is 20. So, if I give the scale, see scale, if you go to the block metric file, convert to meter scale is there. If I define 1, it is meters. If I define point 1, okay, if I define 0.01, it is in centimeters. If I define 0.001, it is in millimeters. So there, if I define the 20 here, so this has to be in the brackets, but that we want to define in our file actually. Here we will write the coordinates. So this will be 0.1 will be 20, comma 0, comma 0. Now 0.2. So this is the 0.2. So the vertices to this will be 20. I will move in y direction. This will be, what is it will be in y direction? See, here when you are defining it actually, I am going to define with respect to symmetry plane. Okay, what I am trying to do actually, so I am going to define with respect to symmetry. So this is what I am going to do. Okay, with respect to symmetry. So then what will happen? This will be 1 centimeter. This will be 1 centimeter. So what I am trying to do actually, I am trying to define only the 1/4 of it. 1/4 of it, what I am trying to do. So 0, 1. So then 0.2 will be 20. So half of 2 is actually 1. So 20, 1 and 0. Then 0.3. Okay, 0, 1, 2, 3. So 0.3 will be, I will come back. So this will be 0, 1, 0. 0, 1, sorry. 0, 1, 0. This is for the first, the bottom, all the vertices are defined. Now I will go to the next vertices, that is 4. What will be the 0.4? 4, it will be 0 in the x and 0 in the y, but in the z it is 1. So this will be 0, comma 0, comma 1. So then 0.5. So this will be 0, so this will be 20, 20, 0, 1. Okay, this will be 20 in the x direction, 0 in the y direction, and 1 in the z direction. Then for the 6, it is 20, 1, 1. Then 0.7 is coming back to it. So this will be 0, 1, comma 1. So now I have defined all the points location. This is called as vertices. What we should define in your block mesh dict file? So you have to define vertices, open the brackets, then within the brackets you have to define all these coordinates of these vertices. So same methodology you have to adapt for any kind of geometry you are going to take. Okay, once you define the vertices, the next thing what I have to define, I have to define, see, geometry definition, I have to go with two things. One is define the vertices, define the blocks, then define the edges. So this is a regular geometry. I don't have any edges. So edges will be simply open the bracket, close the bracket, and with a semicolon. That's it. So now vertices, open the bracket, close the brackets with a semicolon. Within that, I'm going to put all these points. Now let's define the blocks. Blocks actually. Now blocks, open the bracket, close the bracket. No, here I want everything in X mesh. Okay, so here everything I have defined in the order. So I have to define simply X, start with 0, 1, 2, 3, 4, 5, 6, 7, close the bracket. Okay, now, so after this, I have to define how many divisions you want in each axis when you're defining the mesh. Say in the X actually, look at this, in the X, the length is 20 centimeters. So I can divide it into 100 divisions or 200 divisions or whatever it may be. Okay. And in the X direction and Y direction is a similar 1 centimeter, 1 centimeter. I can go with 1 40. So what I will do actually, I will go with 100 divisions in X axis, 10 divisions in Y axis, and 10 divisions. If you need not go with same 100, 10, 10. You can go with 200, 20, 20, or 200, or 300, or 500. So higher the number of meshes, more refined it will be. So it takes more computational time. So this is how you have to do the mesh independent. So there is something called a check mesh option is also there. From that, I can do an independent study with respect to this thing. You can do a grid independent study. You can come up with the what type of mesh I want actually. So blocks I have defined it's X mesh. So points need to build this block. It is 0, 1, 2, 3, 4, 5, 6, 7. I am going to build a block using these vertices. And how many vertices? So now I'm going to go with a simple division grading. Okay, simple division grading. I can go with division grading in 1, 1, 1 or 1, 2, 2 or 1, 2, 1, whatever it may be. Okay, so division grading in whatever the way I want, I can choose it. 1, 1, 1 or 1, 2, 2 or 1, 3, 3. Anything I can go and I can define my division grading. Okay, so here simple grading is one particular thing what we are trying to put. So you have to write the simple grading just after your whatever the 100, 10, 10 division of the mesh, no? That you have to then you have to start with simple. So G should be capital here. So simple grading, and then put either 1, 3, 3 or 1, 2, 2 or 1, 1, 1, doesn't matter. So how we are going to do that? The grading. So that division grading will be depending upon what you are going to define. You can, to begin with, actually, you can start with 1, 1, 1. Okay, to begin with, actually, you can start with 1, 1, 1. 1, 1, 1. Okay, so this is how you are trying to build your block. Okay, so this is how you are going to build your block. So then, once you are done this, just after this, so after you define your this thing, you have your boundaries in the block mesh file itself. So I have to define the boundaries. This is called as boundary conditions. You have to define the boundary conditions. Okay, now see the first thing what you have to define is the name of that particular boundary. So boundary, open the bracket, close the bracket. Then you have 4 boundaries here. Okay, one is inlet, then other one is outlet or exit. Okay, then you have walls. You have walls. Okay, then you have this particular which is called as symmetry. So what are the different types of boundaries you are getting? You are defining this particular boundaries. Okay, now by looking at it, I can tell what are the vertices which are first. If this is the face, so this is the face. How you want to define? See, the type is nothing but usually we go with. See, you have different types of this thing. So wall type. Okay, type of that particular boundary is wall type, symmetry, then patch. Patch means I'm going to define some input conditions, either velocity or pressure, whatever it may be. So the faces for the inlet is 0, 3, 7, 4. Look at this. I have to go in anti-clockwise direction to define the face. 0, 3, 7, 4. See, for inlet, the face is 0, it's not comma, 0, 3, 7, 4. Then at the outlet, the corresponding face is, look at this. It is 1, 2, 6, 5. Okay, it is 1, 2, 6, 5. Then for the wall, okay, for the wall, what and all you have actually? You have, look at this, 0, 1, okay, 2, 3. Then the other wall is actually 0, 1, 5, 4. You have 2 walls and 2 symmetries. If you take, see, if you take this particular thing, let me, if I take 0, 1, 2, 3, see this as wall. Look at this. The one in the yellow, what I'm trying to show, this is a wall. 0, 1, 2, 3 is a wall. 0, 1, 5, 4, this is a wall. So these two things I'm trying to define as the wall. The one I'm trying to show in the yellow. Okay. Now what is left out? Remaining thing is actually, it is 3, 2, 6, 7. So let me go give a different color. So that means 0. So this particular thing, this particular phase. 0, sorry, 3, 2, 6, 7 is one symmetry. Then 4, 5, 6, 7 is one more phase. This one. Okay. So you have to define 3, 2, 6, 7. I'm going in anti-clockwise. 4, 5, 6, 7. I'm coming in clockwise. You have to close that particular thing. So you are trying to define the inlet, outlet, wall, and your symmetry phases. Once you define this, okay. So once you define this, your boundaries are completed. I'm going to define all my boundaries. So all the things you have to put it in the block mesh dict file. Okay. So what are the things? I'm trying to put the vertices, blocks. You don't have any edges here. Edges you have to just open and close the bracket. Then you have the boundary conditions. So once you put all these things, see one particular thing what you have to remember here is actually when you are defining the face, ensure that points are to be prescribed in an order. Okay, either see it should be 0, 1, 3, 7. That means I have to go see in this particular fashion. I have to define the points in this fashion. See how the points has to be defined. How the points has to be defined. Say for example, if this is my 0, 3, 7, 4, I have to go in this fashion. I have to close the loop. At any given point, say for example, I should not define. Say 0, I will go to this particular point 3. From here, I should not define 4, then come back to 7, then come back to 0. So it should not be done. Not only for the inlet, anything you take for the outlet or for the whatever it may be. If I go in one particular direction, 4, 5, 6, 7 or 7, 6, 5, 4, either go in clockwise direction or come in anti-clockwise direction to define the phase of that particular thing. Is that clear? Once this is done actually, so I have to go to your command prompt and type block mesh. What is it actually? It is actually BLOCKMESH. So this is to build the mesh. Okay. Once to check the quality of the mesh, you have a command check mesh. Okay. This checks the quality of the mesh created. So just I given an example. That's it. This is how you are going to build it. The same thing I can do. So one thing I can do is actually if I change the dimensions. So instead of 20 centimeter, I can do 40 centimeters. Instead of making it a square pipe, square cross section, I can make it a rectangle cross section. Only thing is the geometrical things I can change it, but the methodology to define your vertices, blocks, and boundary condition remains the same what I have discussed. Any doubts? If you have any doubts, please unmute and you can speak. Is that clear? Now, if you open the block mesh dict file and all, so it will be clear for you what I am trying to do, vertices, boundaries, and what are the blocks, all those things, what you people are trying to do there. Okay. Is that clear? Shall we move forward? Yes or
Yes,
no?
sir.
Yes. Okay. Now, what yes, define this actually, I told that there is one file, maybe a folder called as constant folder is there. In that, you have a file called as turbulence properties file. Okay, so the turbulence properties file where you have to define a laminar or turbulent, whatever, all those things. Okay, so now if I go to that particular thing, turbulence, the thing, put simulation type laminar. what you do, you have to a folder called as constant folder. In that, you have this file called as turbulence properties. Turbulence properties. Turbulence properties file is there. So in that file, actually, if you are doing a laminar type of simulation, you have to put simulation type. Simulation type. Okay. You set it to laminar. So in that case, actually, you need not define the turbulence. You need not define what type of definition, whether you are going with a K epsilon or realizable K omega, whatever it will be. You need not define it. That means you are trying to disable the turbulence. There is no need to specify epsilon value, K value, omega, V2, all the things you need. You can remove them. Those things you can simply remove them. If you go on, if you are using only simulation type as lambda. If you are using the turbulent type, then I have to choose what type of turbulence model I am trying to define it. Whether it is a K omega model or K epsilon model, or it is a simple RANS model, whatever it may be. So those model I need to define those values. Okay, is that clear? Okay. Once you define this, actually, now the next files what we have to look at is actually how you are going to set up the initial conditions. Look at this. See, there is a folder called as 0. What is this actually? 0 means it is the initial folder conditions, or initial, or few books they define it as the boundary conditions also. Initial or boundary conditions is the folder, 0 folder. It has all these things. But this 0 folder will have majority of most of the things will have two files. One is an U file and other one is a P file. Okay. What you have to do actually, you have to open these two files in your editor actually. So if I open a P file, what you have to do is either use the edit command gedit, okay, Z maybe P. If I do that, so what you are going to do actually there, you will be given different fields. What type of gradient? See, you are going to define the unit of your maybe physical unit of all the values what you are defining. Okay, units of all the values. Then initial conditions. If it is a uniform, this thing it will be 0. Okay, I'll come to that file. When you open the file, you will come to. Then once you are done that, you have to go to your velocity U file. There is a U file. In that, I am going to define the inlet velocity. Okay, I am going to define the inlet velocity as some 0.005 meters per second or some value I am going to define, which I want to define it. Either you can calculate from the Reynolds number, or you can give that particular value of that particular value in your U file, and you can run the value. So it's a fixed value. It's a fixed value. You can define that, and then so once you are done this, you have to define the initial conditions. You have to define in U1 P file. So once you are done this, you have to define the how you are going to do the iterations. Okay, how you are going to do the iterations. So to do that, actually, you have a file what is called as a system file folder. In that, you have the file what is called as control dict file. Okay, so now see in the control dict file, you have to define what type of application it is. It's a simple. So I'm going to go with a simple form. Means it's a incompressible. Okay, you have to define the start time. You have to define the end time. You have to define the time step. Okay, interval, right interval. So if I have 100 iterations, and after every 10 iterations, I want to write. So that is called as write interval. Okay, that's called as write interval. So all those things, what precision you want your maybe your values, whether you want it to be 4 or you want it to be a 6. So usually don't go beyond 6. Okay, 6 is the maybe maximum number. You can go with 4 or 6. Okay. Then if you are going with a time precision also, you can go up to 6 decimals. So then once you are done this, just close, maybe save this, and to run the folder, run the file actually, you have to use simple foam command. And if you want to use the we are visualizing it actually, you have to use what is called as parafoam. Is that clear? So this is how you can simple set up the, see what I told, how you can do the meshing, how you can take the geometry, how to define the vertices, how to define the blocks, and how to define the boundary conditions. So just go to the tutorial folder, take a couple of examples and try to understand what is given there, then that will be clear. Is that okay? Any doubts here?
No, sir.
Okay, fine. So that's okay. Then I will come back to my and share this. Okay. One minute, I'm opening my system folder, desktop. Am I audible?
You're audible, sir, but partially echoing, sir.
One minute, one minute. I'll log out. What about now?
Okay, sir.
Am I audible now?
Yes, sir, you're audible, sir.
No, just saying, am I audible?
Yes, sir.
Am I audible now?
Yes, sir. You're fine. You're
Okay,
audible.
fine, fine, fine. Because I changed my iPad to, I switched over to desktop. Okay, fine. What we'll do is actually, now we'll go to the folder. I'll share it. 1 minute. Just give me some time. I'll try to share the folder. I'm sharing my screen. Okay, fine. Now, yeah, you have to go to this particular folder. So you have this three files, three folders are there. Now you have to go to this system folder. So here you have to open this block mesh dict. Okay, open that block mesh dict. Now, what you have to either, so my suggestion would be create a separate folder. So what I have done is actually have see the OpenFoam tutorials it was there. I made a copy over here. Simply pits daily, I call it as pits daily or something. Here I made this folder and copied all the things over here. So whatever I'm going to do, I'm going to do in this particular folder so that your original files are still kept as it is. I'm going to experiment all the things over here. Now, so this is the what you do actually. Either you can copy this particular file, do the editing, or you can copy everything from the folder and create a separate folder, and you can do the editing. Okay. Now what I'm going to do actually, I'll just go here. Look at this particular thing here. I told that it's a scaling factor, convert to meters. So I told that this particular thing is in centimeter. So I want to convert it to meters. I'll put 0.01. If it is in millimeters, if I want to convert it, I'll put 0.001. If it is in meters, I want to convert it to meters, so it is 1. So that's how this is scaling factor. We call this as a scaling factor. I change it to 20, so I change it to 0.01 so that it's in centimeters. So now you see there are points are there. So because it was an older file I copied. So what I will do actually here, delete everything. Okay. Now open the bracket, close the bracket. So within that first point, I told it is 0 space 0 space 0. Okay, then plus enter. Okay, then open the bracket, close the bracket. So next point, it is 20 space 0 space 0. Okay, next press enter. So next third point. So always you try to open the bracket and close the bracket, then do the editing. It is 20 space 1 space 0. Then plus enter. Okay, then define the next vertex. I'm trying to define the vertices. If you do manually, then you'll understand what exactly. Don't try to simply copy and paste. Everything is there, so all the files will work. So you have to do it manually. The fourth point is 0, 1, 0. Then the fifth point, that is 0, 0, 1. Okay, then press enter. Then open the bracket, close the bracket. Then you have to define the sixth point. It is 20, 0, 1. Then the seventh point. Okay, it has to be 20, 1, 1. Then enter. Okay, last point is 0, 1, 1. So now I defined all the points here. 8 points I have defined. So look at this. There are negative position, all those things and all. You need not do this. You can just simply delete it. This thing, because this is from one of the file I have taken. I'm not moving any negative direction. All those things. Now I have to define the vertices and I have to define the blocks. Okay, I have to define the blocks. So here I will say I don't have so many blocks here. So I will just define only one block actually. I'm going to define only one block. What I will do? Okay, just what are the points I have to define actually? If I go to X actually, it is 0, space 1, space 2, space 3, space 4, 5, 6, 7. So 8 points I have defined. Now block division along the axis. I told that I have to define how many divisions I want in X direction. Let me keep it some 100. So along the Y direction, let me keep some 10. Then along the Z direction, let me keep some 10. Then simple grading. I told I can go with either 1, 1 or 1, or I can go with 1, 3, 3 or 1, 2, 2, whatever I want, I can do that. So I have defined the blocks here. This is the division grading. Then I have defined the points needed in the blocks. It is 0, 1, 2, 3, 4, 5, 6, 7. Okay. Now what is the next thing I need to do? I need to define the boundaries. Okay. So to define the boundary, I told that I have to define in the boundary like this. Okay. Boundary. So I have only 4 boundaries here. Inlet. What type it is? Patch type. What are the faces? It is actually, I have to define it is 0, 3, 7, 4. That means that particular face consists of 4 vertices. Then outlet, once again its type is patch. What are the faces? It's a single face. Okay, it's a single face. So it is actually, it should be, I told that it is 1 to 6, 5. So 1, face 2, 6, 5. All the 4 faces. Then the third one is the wall. Okay, it is the wall. Let me delete it. It's a wall actually. It's a simple wall. Okay, what type it is actually? It's a wall. So it has how many faces? It has 2 faces. Okay, 2 faces which is already there. I'm going to delete. So I'm going to go with only 2 faces. So what are the faces? It is 0, 1 and 2 and 3. It is 2, then this is 3. Then the other wall, actually it is 0, 1, 5 and 4. So 2 faces for the wall, and I have to define the symmetry. So for that actually we call it as symmetry wall. I am going to define SYMMETRY. Then for the wall it is capital is W. Symmetry wall. What it is type actually? So the type is symmetry type. So I have to type here SYMMETRY. Symmetry. And what are the faces? So only 2 faces are there. The rest all I am going to delete. Okay. So 2 faces, that is 3, 2, 6, 7. 3, 2, 6, 7. Then one more face I am going to define. It is 4, 5, 6, 7. So now my block mesh dict file is ready. Okay. So block mesh dict file, I have defined the vertices, I have defined the blocks, and I have defined the boundary. So you have to save it. Okay. Once you save this, I am going to define all the things. I have saved it. So once you have to cross check. You have to cross check all those things and you can define it. As I told, your whatever the faces you are going to define, they should not do any kind of, see, the faces should not overwrite, or it should not, there should not be any cross in this. So once I've done this, I'm going to close this. Once I'm going to close this, and I'll just open this in the terminal. Okay, just I'm going to type. Okay, so I'm going to type block mesh, BLOCKMESH. System folder. Yeah, fine. Symmetry wall, everything is defined. Point number 15. Something missed out. 0.01. Block mesh it. It's daily. 0, 0.
Sir,
Yeah.
So one brace is not closed exactly down.
Where exactly one brace? Which point?
In between only, sir. So yes, sir.
This one, huh? Oh, that's closed, no? One minute. I just one brace here, one brace here. That's closed. Okay. Then all the rest in the braces. Then one brace here, one brace here. All the braces are there. It's fine. Edges closed. Okay. Then what else? Actually, inlet. So this is one this thing, and here is one closed. Then I've defined one brace here, one brace here. So in between. Okay, this is fine. Outlet, it is type patch. One brace here, one brace here, 1, 2, 6, 5, it's closed. Then type wall, it is one brace here, one brace here, 1, 2. Oh, actually one brace is that. This is extra thing. I think wall, upper wall. No, I think I made a mistake. There is no upper wall here. Okay, so there is one extra here. Look at this. I should remove this. That's an extra thing. That's what I left it. No, when I deleted, no. Okay, one wall I removed. Yeah, now it is there. So now, so this is the wall 0, 1, 2, 3, 0, 1, 5, 4. Okay, now it's fine. Now it has to work. Now it is fine. So I have inlet, outlet, wall, and symmetry wall. Yeah, wall and symmetry wall. Everything is fine. So 3, 2, 6, 7, 3, 2, 6, 7. Open the bracket, close the bracket. Now this has to work. Clear. Yes, now it is done. Look at this. So now I got the mesh. I got the mesh. So this particular thing, everything is fine. The only thing is there was some extra. So everything is now the block topology and all. Now if I want to check this mesh actually, so I have to go here and I can type the command. What is it actually? CHECK capital MESH. CHECK capital MESH. This will give the check mesh. Okay, so you are going to give the geometry, what are the things, how many faces are there, all those things you will get all the information. So just I given 100 this thing. So if you want, you can go with so totally. So I have how much actually 10,000 hexaeder meshes. Okay, 100 into 10. Okay, into 10. That's the meaning of it. So I have around 10,000 hexaeder meshes. So many cells are there. So now I created the mesh and I have created the your what we call it as maybe your mesh, and I check the mesh quality also. Okay. Now I have to go to this next file, that is turbulence properties. Okay. To do that, what I have to go? I have to go to this constant folder. Okay. So here all the things you remove, polymesh, all those things you remove. So I have only transport properties. Just go here and edit in the text editor. Okay, transport properties. What is it actually? All the things are there. This is so dictionary. This is a turbulence properties. So you name it as turbulence property. TURBULENCE. I think transport. Even the file also has to be named to turbulence properties. So what type of simulation type? I think I don't have turbulence. 1 minute. Okay, I will rename it. It is turbulence properties. This turbulence properties. I'm going to rename it. Okay, I will open it in the text editor. Okay, and this also I'm going to change it to turbulence properties. What is the thing first? I need to what type of simulation type it is. So I have to type SIMULATIN capital TY, the simulation type, it is laminar. Okay, then close with a semicolon. Okay, then if you want, you can define the properties. Okay, so you can define the properties, or you can just define the, so you can If you want, see, usually what will happen, no, if you look into that particular file, in the simulation, in the K-epsilon turbulence properties, you'll be having something like this, RAS. So open the flower bracket, then close the flower bracket. Within this, okay, within this actually, so you'll be having this kind of property, something like this. So you'll be having all the properties. So whether K epsilon or K epsilon or K omega, okay, K omega SST, etc., etc. All the things will be in the commented. Okay, there you have to define the RANS model, what you are doing. That is your turbulence model. That is RAS model, MODL. So simply say, for example, let me define, I'm going to define K epsilon. SILOAN, K epsilon. So here, once you've done this actually, maybe here I can put, if I want to do this actually, turbulence, you can keep it on. Okay. Then if I have to go with that coefficient, what you are trying to do, no? Print the coefficient. This also you can keep it on with a semicolon. K epsilon with a semicolon, and rest all you can delete it. Okay, so you have to go to this particular file and you have to define this actually. Turbulence models are, turbulence models are defined in turbulence property, this thing. So here there are no turbulence, so just I am trying to give laminar. So if you just give the laminar, if you give turbulent, then those coefficients is going to take. So what we have done is actually, the moment you define this as laminar, we have disabled the turbulence, and you need not define the epsilon value, omega value, all those things. Okay, so then what will happen, if you go to this your zero folder, in that case you come to this zero folder, okay, you can remove the epsilon, omega, see all those things you can remove. So K, this also I can remove, okay, epsilon I can remove, okay, F I can remove, okay, then all the values, this also I can remove, then not TDLA, this also I can remove, omega also I can remove, V2 also I can remove. So in the your initial conditions or boundary conditions, I am left, because there you have to define the value. See, you have, if you are defining it as a turbulence, you have to define the values over there. So that values are there actually. So here I am trying to make it laminar, so you need not have those files with the values in that particular thing. So you are trying to disable all those things. Just we'll check with a laminar flow. If it has turbulent flow, we can do turbulent flow also. That also we'll try to look in the future classes. Okay. Once you are done, you save it and come out. Okay. Then you have to go to initial and boundary condition. That is, I have come to this 0 and P folders. So now you come to this P folder, so 0 folder, and click on this P file. Okay, click on this P file. So you have so many things. So here, look at this particular, what type of it is, scale. See, the far field boundary condition, this object is P. I have to define the dimensions. So what is it actually? See, usually that is the physical field unit. Okay, usually this is the dimensions what we have. So that is actually, this is for CD, kg, then meters, all those things. So just look at it actually. So don't do anything over here, just leave it as it is, whatever is there. Usually by default we'll try to leave it. Then what type of internal field it is? Uniform 0. Then the boundary field. Okay, the boundary field actually at inlet actually it is 0 gradient. At inlet it is 0 gradient. Then outlet it is actually, I'm going to give it as once again uniform 0. Then you have the wall. It is not upper wall, it is only wall. Okay, it is wall. Once again it is 0 gradient. Then what else you have? You have symmetry wall. Okay. you have the symmetry wall. I'm going to type that SYMMETRY, symmetry wall. So it is actually what type? Actually, it is symmetry type. SYMMETRY. So zero gradient and a fixed value, then zero gradient and symmetry. So then this particular thing, it was there in the earlier file, that you remove. That's it. So now your P file is ready. Your P file is ready. P file is ready with this particular thing. Then save it. Save it. Okay. Then you have to go to U file. Just click on this, edit it actually. So here U file actually you have to given these dimensions. Look at these dimensions. Once again this thing. Then what type of field it is. So here I have to give some value for the velocity. So let me start with some 0.005 or 0.005, whatever it may be, 0.005. Okay. Then the outlet is zero gradient. One for the wall, I have to define it. So for the wall, okay, it is a fixed value with a uniform 0, 0 velocity. So type it's actually, I can type it as a fixed value because the value on that particular wall is 0. Okay, it's a velocity. So the value, then so you have to go to the particular thing. It is uniform. Just copy this. Let's copy the same thing over here. It will be easy. Okay, it is 0, 0, 0. That's it. The fixed value it is 0, 0, 0. Then you have the symmetry wall. So this is for the symmetry wall. SYMMETRY. The symmetry wall. The type of condition is actually it is symmetry. So I have defined the U file. Okay, U file, where you have the inlet, outlet, wall and symmetry wall. You are defining all the values. So once you have done all these things, so just cross check with the brackets and all. Just cross check with the brackets. Just open and just save it and close it. Okay. Okay. Now I have this. Now I have to go to the 0 folder. You have U and P. Then in the constant folder, so you have only turbulence properties. Okay. Then in the system folder, you have block mesh dict, and the last thing is the control dict actually. So just open that control dict actually. Then look at this particular thing. It's a simple foam. So start time is this particular thing, and 0 end time is, so you can give anything. If you want, you can change from 2000 to 100 or 200, whatever it may be. Let me give some 100 to begin with. Then what is the time step? Okay, so time step. So let the interval, let it write for every 100 means let it write for every 10 steps it is going to write. Okay, then the writing format is ASCII format. It's a common thing. So let the precision level be 6 for both writing the values as well as for the time. So rest all the things you leave it as it is. Okay, so this is your run. Then the rest all the things you can. So if there is any K epsilon and all, you have to do it. Otherwise, once you are done this particular thing, these things you have to remove. Because if you are using a turbulence thing, then you have to give those values. Okay, once you are done with the runtime, true, just close this particular thing. Yes, yeah. Now all the values are there. So now save this. Save this. Just go here. Now you can run the case. You can run the case. So just come over here. Simple foam. Something. create a mesh. Where it is, polymesh is there. No, 1 minute. Okay, block mesh. Then there is an error actually. Finite volume schemes. Okay. Yeah, finite volume scheme. That file should be there. 1 minute. Go to this. Yes. Now it has to run. Transport properties. Transport properties. Seeing some error. Transport properties. Transport properties. No, it's not transport properties. Should be. Turbulence properties. This is fine. Yeah, fine. It's working. Yeah, it closed with 22 iterations. I think while deleting, I deleted some more files. That's why it gave some error. So transport properties file, I think I deleted. Okay, so now I think it has converged at. You also do the maybe be careful when you are deleting some files. Yeah, it has taken some. If you are building all the files from scratch, that's fine. But you are taking one folder and deleting something, it may be accidentally you may delete one file and all, it won't work. It has taken how many iterations? 20, 16, 17, 18, yeah, 22 iterations it has taken. So let me clear this. So you want to view this actually, just type para home. Yeah. Click apply. Yeah, it's come. Look at this. I got this thing. It's a square thing. It has come. So this is how it is. You apply this particular thing. So now, so you have to do the post processing. Okay, you can do post processing. What are the post processing I can do? So you can do some slicing, and if you want, you can do some plot over the line. All those things you can do. Okay, if I want to look at the velocity, how it is going over there, just go here. Okay, you can see this velocity, how it is, this particular thing. Then if you want, you can just click on this particular thing. This is what I am trying to see, the velocity from inlet to outlet. Okay, this particular, if you want, you can create one slicing. See, look, there are certain things here. Okay, there are certain things. This is called as a slicing. I am going to create a slice. So filters, you go to this particular thing. Okay, filters, then here I can come to slice. Look at this. Either you can use this particular thing. Okay, either you can use slice or you can use the fourth command over here. Okay, fourth icon here, this is to create a slice. So where I want to create a slice, look at this. Whether you want to create the slice in this direction, whether you want to slice in this particular, let me define this, yeah. You want to do the slicing in this direction, okay, you can just go here. So if you want to keep it is Y normal, click on that, okay, click on that Y normal, okay, then you apply it. Okay, that means I'm going to create a thing in the Y plane. Are you getting slice? I am trying to do a slice in this particular thing. This is nothing but, if you are doing something in your ANSYS Fluent, it is nothing but the cutting plane. So here they call it as slicing. So use this particular thing. So this is the fourth icon here. Or if you go to this filters, common, you have different things, clip, slice, all those things and all. So click on this slice. So which direction you want in Y, X, or whatever it. So usually if you want to see here, I want it in Y direction. So I am trying to do this. So if you want, you can zoom this. Now you try to see the velocities. How this particular thing you have defined. U magnitude. Sorry, if you want to see the pressure, just you have to do this. You can see how the pressures are varying. Just simple. See, just I'm trying to define. I'm not going with any actual values, all those things and all. Just trying to teach you how you can do simple mesh. Take the mesh, how you can do it in the block mesh text file, and how can take. I'm not going with any actual values and all. Okay. Now, here filters, you can do a little bit of few more things you can do. So you can do some data analysis. Okay. So here you can look at some integration values, all the things you can do. Or if you want to do some kind of, let's try with plot over the line. Okay, you can see the plot over the line, okay, along this particular thing, along Y axis, along X axis, along Z axis. Okay, if you want, you can do that actually. Plot over a line, if you want, you can do. What it is going to do actually, it is going to calculate that particular values. Okay, it's going to calculate that particular value. Check velocity profile. So what is the velocity profile? Maybe if you are doing some kind of an analysis for a pipe flow and all, if you're using a pipe flow analysis and all, you can usually do this. Maybe I'll try to, maybe in the next class, I'll try to teach you. If I take a pipe flow, so if you define it, actually, I should be able to get a parabolic profile. How to get the parabolic profile? See, if I try to do this analysis, that is, if I try to do a data analysis, try to plot over a particular line, that means I'm going to create a plane in that particular direction. That is, if I try to take it in X direction and try to plot along it, I should be able to get a parabolic profile. That means from here to here, if I try to plot it, it should be like this, parabolic profile. You should be able to get it. So this is with respect to a slicing, how the velocity or pressure will look like. Or if you want to look at the vectors, the vector also you can look into that actually. Okay, if you want, you can look into the vectors. Okay, vectors also you can look into. So I'll get the vectors, or maybe if you want to look at the wireframe, this is how the wireframe will look like. If you want a wireframe with edges, you can look into this. So this is to bring everything. This is the wireframe with the edges. This is only wireframe. That is, you don't have any surface. So usually preferable is actually, so whenever you're doing some kind of a pausing and all, so you have to go with the surface. So wireframe is the last option. Always go with the surface, and then you try to do the post, maybe what we call it as maybe post processing. Okay. So what I want is actually, maybe I'll try to give one simple work for you all. Okay. Let me stop the recording here.